Hi, this is Ike. Today we'll be working on creating a text-based tic-tac-toe game where the computer will be playing against the user and the computer will just be taking random movements. So let's go to our PyCharm on the left and create a new project. We already have the tic-tac-toe folder, so we'll put it in another folder called code, create the virtual environment, and click create. Okay, so everything's done loading. Let's right click on the main project folder, click new, Python file, and we'll just call it tic-tac-toe. And just like the previous tutorial, we'll start off by creating a main skeleton for our program. Uh, we're basically creating a default entry point for the program. We'll run the main function in the global scope, and then that'll run everything in here. All right, and also similar to the last tutorial, we want to create a class for the tic-tac-toe game. And in here, we'll just put a pass. Okay, so let's make sure that everything is good. We'll run it. We see process finished with exit code 0, so we're all good. Okay, so the first thing we want to do now is a little bit of planning. So I'm trying to think now of what should go into what comprises a tic-tac-toe game. So the first thing we want to do is display the board. And number two, I think we'll probably want to get player movements. And then with that, we need to also get computer movements. And then we probably need to check for a winner. And there's probably some steps in between these, and we might even think of a few as we go along and come back and update. But yeah, just thinking of this thing here, we start off with an empty grid. We got to display it. We need to get the player movements, get the computer movements, and check to see if anybody won. Okay, so let's get started. First thing I want to do is go into the main function and just create an instance of our tic-tac-toe class. And this should run. Okay, so let's get started on the task of displaying the board. We'll create the constructor, move this pass here, and to display the grid, to display the board, we're going to need a way to represent the board in code. And the way I'm thinking of that, this is just a grid essentially. And an easy way to represent a grid in Python is probably going to be using a 2D list. So let's say self.board equals, and before we fill it in here, we actually run some quick experiments in the Python console below, just to test out our ideas so we know that they work when we type it up here. Okay, so what is going to go into our board? We know that there's X's, O's, and spaces. And by default, the board starts out with all spaces. And in Python, we'll technically need a list of lists where the greater list will contain three smaller lists, or the greater list will contain three lists which just have spaces in them to start. So essentially we want to see something like this. So we'll have a greater list and three lists inside of it. And I'm just going to write, I don't want to type in a whole bunch of quotes, so I'm just going to say we should have space, 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 space. Okay? And how can we make something like this? So we're actually going to use something called a list comprehension. Um, we'll first start out by trying to make something similar to this here. So let's actually move down to the console where we can just type in expressions directly. So list comprehension, we're just trying to make a list with 3 spaces in it. So for the list comprehension syntax, I sort of like to just think of it in terms of what I want. I want a space, and how many times do I want it? Uh, we want it 3 times. So a space for I in range 3. And perfect. So that gives us a list with 3 spaces in it. So let's just take this and put it up here. We're definitely not done yet. We still need to actually make 3 of these things and put them in a larger list. But you can see that it's basically the same concept applied twice, because now we know we want this thing 3 times. So we'll use the same concept as before. We'll create a list, and then what do we want? We want the list with 3 spaces. How many times do we need it? We need it for j in range 3. And I just like to make sure to use a different variable for clarity. I think it'll still run if we use I, but it's probably a better practice to use a different variable right here. Okay, so let's click enter, see if it gets what we want. Perfect. So we have a list of lists where each of the inner lists is just a list of 3 spaces. Okay, so we can take this code here and just paste it in for the definition of self.board. All right, so now that we have a board, we need a way to display it. And how do we want it to look like? I think we can essentially just copy the format here. So we can create a grid that looks something like this. We'll put in X's and then the little bar thingies. And just put in, oh, whoops. Oh, and we can have like the bottom bars too. We can just use dashes for that, and so on. So I'll just copy this down. Okay, then we want this. So essentially we want the representation of our grid to look something like this. So this is just a quick way to sort of imitate a grid like we see on the right. So how can we do this? Before getting into doing this, let's actually think of the means to display the grid. So that's how we want it to look, but we actually need to, like, where are we going to put the code to display the grid? So down here, I'm going to type print t, and let's run it and see what happens. We get main.tic-tac-toe object at 0x0000 and some other stuff. And this is basically the default thing it prints out when you try to cast a class to a string. We just get like what type is it and its memory location. But this is something that we can actually customize for our class. So I'm going to go to Tic-Tac-Toe and create a new function called __ string. And here, all it needs us to do is return the string representation of the object. So just as a test, we're going to say this is a tic-tac-toe game. Okay, so now when we print t here, instead of seeing all of this stuff, we should see this is a tic-tac-toe game. So let's run it. Okay, perfect. So now let's work on translating this into code. So essentially we know the form of the grid. So what we basically need to do is transform each of these smaller lists into a string, and then combine all of those strings into a greater one. So essentially, if we look at this example, we take this row, turn it to something like this, take this row, turn it to something like this, and so on, and then combine all of these into one greater string. So to do that, let's start off with a result, and we'll set it to an empty list. And now we'll say for R, or I'll just say row to make it more clear. So for row in range 3, and we're doing this because we know for sure we have 3 rows. So for row in range 3, we're going to say, actually let's change this because I want to use row as a variable to hold the string. So we'll just say for R in range 3, we'll say row equals, and let's just focus on one thing. We just want to take a list like this and turn it into a string. So instead of something like space, comma, space, comma, space, it could become 3 spaces, or x, comma, x, comma, x. It would just be 3 x's. So we can actually do this fairly easily with a method called dot join on a string. So we'll basically put in a delimiter. In our case, we want the delimiter to be a space and then a bar. So we'll say row equals space bar dot join. And what do we want to go into the join function? Well, we know we have self.grid, and we want to take the current row that we're at. So that would be row equals delimiter dot join self.grid at the current row. And it seems to be, oh, I think we should be using void. Okay, so hopefully this should actually give us the row we want. And we can actually test this out by printing out row. Because since we're running print t here, this method's running, so we should actually see output from this for loop. So let's run it. So we still see that this is a tic-tac-toe, but above that, we get a little bit of our grid. So remember that everything started off with spaces. So we see nothing here, and then a bar, nothing here, then a bar, and then nothing else. So it's starting to look like this. So the next thing we need to do is actually put in these bars under. And so the thing with these bars is we only need to put them, these on after every, or we only need 2 of these bars to separate the 3 different rows. So let's think about how we can do something like that. So at this point, we have 3, we're creating row strings. What we want to do is add them to the result. And so let's print result just to see if that worked. Okay, so then it kind of changed how it looks really strange now since it's all flattened. But essentially, this is sort of the same thing as before. We just added all of those rows to a list. And now we're going to recycle some of the things that we just did. So the result is going to be equal to, because now we have 3 strings again in a list, and we want to join them, but the delimiter, instead of being a space and a bar, it's actually going to be one of these long sequences of dashes. So we can actually say result is going to be equal to, let's actually copy this. Dot join result. Let's take out the print statement. So now essentially we are joining each of these rows with a string of bars or a string of dashes. Okay. Now let's remove the this is a tic-tac-toe game and return result. So we should just see the output of the print statement. Reformat, run. Okay. So we have a slight problem. It's kind of what we want. So we technically have a row here, but then the dash is on the same line, and then another row here, then a dash is on the same line. So how can we fix something like this? So essentially we just need to put a new line after each one. I guess we also need a new line before each one as well. Uh, so let's partly fix it by saying we need the delimiter, instead of just being a sequence of dashes, should be a sequence of dashes and a new line after. Let's reformat. Let's do run. Okay, so this is a little bit better. It still looks kind of weird, but now we have the first row, but the dashes are right here. Second row and dashes. So we still need to do something else to put we still need to put the dashes under in both cases. And I think we can probably just fix that. Instead of just adding a new line after, we can add one before as well. So let's try that out. Okay, perfect. So now we kind of have a representation that's similar to the one here. And once we're able to actually fill in X's and O's, we should see, like, instead of a space, we'll have X here, like O here, and so on. All right, so I think that's actually good for the representation portion. So display the board gets a check. Okay, so the next thing is getting player movements, but I just thought of something else. We'll call this 1.1, and we need a way to run. We actually need a way to run the game. So similar to the number guessing game, let's go down here and create a function called play. Put a pass in there. Okay, and so when we're playing though, we need to tell if the game is still running. So let's have a variable here called self.gameOver is false. Okay. And here in the play function, we'll say while it's not the case that the game is over, we can collect player movements and collect computer movements and check for the winner. And remember, we'll need a pass here. And reformat. So what should we do first? Get player movements. So that calls for another function, I'm thinking. Let's just call it player move. Add a pass here. So while we're still testing this, because we'll want to test the play function, but if we just have a pass, then since this is a while loop, it'll just keep running. I'll just say break, so it's just going to do one iteration of it and break. Okay, so the player move, we essentially just want to know where in the grid the player wants to place their piece. So we'll say player uses an X. And how can we get input from the player? We just need to know which row they want to go into and which column. So we'll say player input will be like RC. So in the command line here, when we run the program, we'll just the player will just type in a row and a column separated by a space, and that will basically let us know where we'll place the X. And how can we do that? So we'll say move is equal to input. Say uh, please enter where please enter your movement, or let's say, yeah, please enter your movement, and we'll say it should be in format like this. Let's give them more of a hint in a space. So now they should be able to enter in, now they should be able to enter in a string. And let's test this real quick. So we'll just say print move, delete the pass, and format. So down here, we've created a tic-tac-toe object. We've printed it out. Let's now say t.play. And then we need to do one more thing though, because we called t.play. And let's go up to the play. We have while the game's not over. We actually need to call player move. So collect the player's movements. We'll say self.playerMove, reformat, and let's run it to test this out. Okay, so we see the grid from the initial print statement, and then from t.play, we do the player move. So please enter your movement. So I'm going to say 0, 0. And cool. So it printed out the movement that we entered, and then broke out of the while loop, and the program finished. So now let's actually try to process this, because this is just a move is just a string now. We actually need to get the numbers that were input. So let's see how we can do that. We can say move equals move.split, and we'll give it a separator, which is just a space since they're entering row space column. And this should give us a list with just zeros. But we can test it out real quick. We'll go with 0, 0 again. Perfect. So we see move, after doing move.split, we get a list with the string 0, comma 0. Okay? So we're still not quite done yet though, because we can't really use these as strings. We want these to be integers so we can actually use them for indexing into self.board. Okay, so let's do, okay, so let us do move equals, when we'll use a list comprehension again. We'll just say move is going to be equal to the int of m for m in move. And all this does is gives us a new list with everything that was in move, but casted to an integer. And so now when we print move, hopefully we should see the number zeros instead of strings. Okay, cool. So we have 0, 0. All right. And another cool thing we can do in Python is we can unpack this list by saying, since the list has 2 elements, we can actually assign 2 different variables values at once. So say row column is going to just be equal to move. And if we print, we can say print row, print column, just to make sure it worked. This time let's type 1, 2, and perfect, we see 1, 2. Okay, so let's remove these print statements. And now we actually need to play our move. And so to do that, all we need to do is place an X in the position that the player tried to move to. So we'll say self.board at row at column. So we're just indexing into the 2D list is going to be equal to an X, since the player uses X's. Okay, so we'll give it a reformat. And yeah, let's test it out. So what we'll do is we'll go down here. We have player move. Uh, so actually, like after someone does a move, we should probably print out the grid just so we can see what happens. And remember that in a method, self is the object. So in this case, like uh, self would be t. So we can just say print self. And it'll be the same thing as saying like print t. So let's run it. We'll do 1, 2. And perfect, we see an X right here. So remember it's 0 index, so this is row 0, this is row 1, or this is row 1, this is row 2. So then we said 1, 2, so row 1 at column 2, so then column 0, 1, 2. So we see that this worked. Okay, so now that we have the players move, we can go to doing some error checking. I just realized that since we're just setting the move directly, we could essentially overwrite what we previously had in the grid. So let's just say if self.board is equal to a space. That's the only way we should be able to put something in that spot. And so if not, then we need to get the player's move again. And I think we can just go ahead and call self.playerMove once again. Because so basically if the space was empty, then we just place the X. But if not, then we want to go through the whole process of asking them for their movement and so on. We can put a little message here too, just to let them know they need to try again. We can say the location was or is occupied. Just say no, please. Just try again. Put some parentheses around this and reformat. Let's pull this to the left. Okay. And I want to stay consistent with the quotes, so I'm actually just going to replace these with single quotes. All right, so then we've got the player movement. We check to see if it's valid, and then if it's not, we have them try to move again until they get it right. Okay, so I guess we can't really test it out right now since we're breaking here, but we can try it. So let's remove the break statement and reformat. We'll just click run. So let's go to the top left, which would be 0, 0. So let's say 0 space 0. And we put an X there. Let's try to put it there again. And said the location 0, 0 is occupied. Try again. And maybe let's try the space to the right of that. So cool. So now we see 2 X's. And so that shows that our error checking worked. Okay, we'll have to stop it like this since we're in an infinite while loop. Okay, so we've got the player movements. Now we need to get the computer's movements. So let's go down here to play. We'll actually need to make some modifications to this function, I think. But first, we're going to do that in the constructor. because we need to know whose turn it is. So I'll just say self dot players. We'll say is player turn, is player's turn. Let the player go first. We'll say is player's turn is equal to true. And now down here in the play function, because we only want to collect a movement if it's the player or the computer's turn. We only want to collect one movement at a time. So we'll say if self dot is player's turn, then we want to collect the player's movement. Else, we'll collect the computer's movement. And so let's create a function here called computer move, put it past there, and then fill it in down here and reformat. Okay. All right, so remember we were thinking about having the computer move randomly. So we can actually do that with some of the things we learned from the last video. I'll go ahead and go all the way to the top and import random. And go back down. So we'll say the row will be equal to the random dot rand int. And so the lower end will be 0, the higher end will be 2, because this is actually inclusive, so we can get values of 2, like anything from 0 to 2 inclusive. So we won't put a 3 at the end of here. And then the column will basically be the same thing, random.randint, 0 to 2. And we'll do something similar to what we did for the player move. We'll just say, okay, let's do self.board, row column will be equal to O. And just like we did for the player, we probably want to have some error checking. So we'll say if, I'll just copy it from here. If the board at row column is equal to space, then we can go ahead and set it to an O. Next, we need to see what to do if this space is occupied. So let's go ahead and think of how to just rerun this. We could just sort of do the same thing, say self.computer move. I know many people are not going to like the recursion here. We can also use a while loop and just keep checking like this condition. But I think we could also use a while loop to keep checking this condition. But I think it's more simple or easier on the eyes to just have try the computer move again. Like if our move was invalid, then we just try to move again. Okay. So we have while not game over. If it's the player's turn, let the player move. If it's the computer's turn, then let the computer move. And so after each turn, we want to flip whose turn it is. So that's at this point we'll say self.isPlayerTurn equals not self.isPlayer's turn. Okay. And now we want to focus on checking for the winner. So let's add checks by these. Let's just go right ahead and actually before checking for the winner, we probably want to test to see if all this stuff worked. So we're going to do, we have a print statement here. Let's actually remove the print statement here, and we should be printing out the grid before not T. We'll change that to self. We want to, when we start playing, we always want to see the empty grid. So we'll print out self here. Then we can just say T equals tic-tac-toe, and then T dot play. Okay, so let's go up and run this. Please enter your movement. So I'm gonna just go with the middle. Let's go 1-1. And so it did that movement, but the computer went immediately after. So you kind of see these two different grids here. Like this was my move, and then it printed due to the computer's move. Let's actually print out some more information for the computer's move. So we'll say print the computer placed an O in. We'll make this an F string so we can put our variables in. Put an O in and what do we need to put? Row and column. Yeah, the computer placed an O in row and column. Okay, let's see if that works. So let's stop this and run. So we'll go 1-1. Then we immediately see the computer. We went here in the middle. Then the computer 2-0 is just going to be the extreme bottom left. So then here's the current grid. Let's do another one. Let's go to this right here. So this will be 2-1. Oh shoot, computer knows its stuff. Let's cut off the computer by going 0-0. So yeah, we can see that the sort of basic functionality of the grid works. We'll put in the winning location here. Of course, we haven't coded the check for winner yet, so this will not work. But let's just go ahead and do 0-1. Okay. So at this point, let's stop the program and move on to checking for the winner. So let's format. And what's this complaining about here? Oh, whoops. Oh, that is true. I sort of messed up the naming conventions, but that's an easy fix. In Python, I think we do lowercase and then underscores between the names. So let's rename. Let's call this computer underscore move. Do refactor, and this one we'll do refactor rename. Player underscore move. Do refactor. Are there any other offenders here? Nope. Okay. So we have the play, and we want to check for a winner. Alrighty. So what entails a winner? We need 3 in a row, horizontally, vertically, or diagonally. Okay? So then we just need to check these different cases. So if we go up to, I guess we can use the thing on the right. We just need to check if there's a winner here, here, here. That would be horizontally, then vertically here, and then just 2 diagonals. And that'll be enough to check if there's a winner. All right. And to do this, I'm thinking we could do something where we just have a base, basically a base list or tuple of X's and O's, because I don't want to keep creating one each time. So let's go up to our constructor. We'll say self.playerWin is going to be equal to X and self.computer win. I'll just do this. Say O, 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 and reformat. Because essentially we just need to check, we need to aggregate all of these things in their own individual lists and see if they equal either one of these. So we'll move back down to check for winner. So let's start with the horizontals, because I think these will probably be the easiest. We'll just have to go through, I think we can actually directly check because self.grid, say at like 0, or not grid, sorry, board. Self.board at 0 will just be this entire list, and self.board at 1 will be in this entire list, and so on. So we can just say if, if self.board is equal to player win, self.player win, we can just return X, like if the player won. And we'll say else if computer win, then we just return an O. Okay. And we don't want to do this, just for the first row. So we'll actually go through a for loop. We'll say for I in range 3, put this all in the for loop, and replace the 0 with the I. Okay, now let's do the verticals. Now let's think of how to do this. It'll be fairly similar to the horizontal case, but we don't have the entire columns just stored as lists, so I'll actually have to create these lists on the fly. So here we can say we can say something like there's 3 columns, so we'll say for J in range 3, first we need to create a list representation of a column. So we'll say column is going to be equal to, we'll use a list comprehension again. So remember, for a column we need to go downwards. So we'll say the column is going to be self.board at J, and it's actually I'll change these variables around because that's kind of confusing. So we'll keep using i's for the rows because we want to stay at the same row, but we just want to move down that row. So like say if we're at oh wait, actually sorry, let me go back. So J is the column. We want to stay at the same column and move down the rows. So we'll say we want to get self.board ij for I in range 3. So essentially what this does is J is the variable that's sort of fixed each iteration. So all this is doing is we're fixing J, so we're fixing the column, and then we're changing I. So that means we're fixing the column location. All right, and we can essentially copy what we have here. But since I think we're going to be using this code quite a bit, so we'll actually make a function for it. We'll say def check line, and we'll add a line. And here we'll say if line is equal to self.playerWin, return x, else elif the line is equal to self.player or computer win, return O, and if it was not either of those, we just want to return none. Okay, let's reformat. So now we can actually go ahead and say, we can say win equals self.check line, self.board at I, and then now we can actually delete the rest of this stuff. Okay, and we'll say if win is not none, then we just want to return win. And we'll do the same thing here. We'll say win is equal to self.checkLine, but this time we want to do it with the column that we just created. And if win is not none, return win. Okay, so let's do the diagonal portion. Okay, so now we'll be doing the diagonals, and these ones will be a little bit more tricky, but not too bad. So we'll be, instead of just going straight in one direction with the rows or columns, we'll be going diagonally. So we want to get position 0, 0, 1, 1, 2, 2, or 0, 2, 1, 1, and 2, 0. Okay? So how are we going to do this? Let's think of how we can grab all of those things. So let's try, so we'll say the diagonals. Let's go from, we'll do from the left first. And to go from the left, that's the case where we want 0, 0, 1, 1, 2, 2. So we're actually going to use something called zip. And what we can say here is we want so we'll say left diagonal equals we'll once again use a list comprehension. We'll say we want self.grid at I, j, for I, j, in zip. I'm just going to type this out and then explain it after. I know this is kind of a lot. I keep typing in self.grid for some reason, and then reformat. And let's move this a little bit. Actually, let's collapse this. Okay. And so let me explain this line, starting from the zip. So we know what range 3 does. That basically just gives us 0, 1, 2. So let's go down to the Python console, type in range, or type in list of range. We get 0, 1, 2. And so what zip does is it basically combines two iterables. So when we do zip range 3, we basically get something that's combined. So we'll see 0, 0, 1, 1, and 2, 2. So we'll say list zip range 3, range 3. So essentially this ties together the 0, 1, 2 with another 0, 1, 2. Okay? And then what we're doing here is in Python, you can actually unpack the list that you're iterating over. So see how we basically have a list of tuples, like 0, 0, and 1, 1, and 2, 2. So we're just saying for ij, like in this case, I is equal to 0, j is equal to 0, and then I is equal to 1, j is equal to 1. So we're just saying for ij in zip range 3, range 3. And then we can use those to directly index into the board. Okay? And now we can just say win equals self.check line, and we'll put in the left diagonal. And we'll say if win is not none, return win. Now we'll do it with the right. And I'm actually just going to copy all of this because it'll be exactly the same except one small change. So we'll change this to right diagonal. But remember, for the right, we don't want to get 0, 0, 1, 1, 2, 2. We actually need to go the other way. And that other way would be doing 0, 2, 1, 1, and 2, 0. And how are we going to do that? Well, it's actually a pretty quick change because notice that all we did was reverse one of the ranges. So we're still going in the same order by rows. So we still need this range 3 for the rows. It's the columns that are reversed. So instead of going from column 0 to 2, we're going from column 2 to 0. And we can make this change just by saying reversed range. Okay, so we'll say we have the right diagonal, and win will be self.checkLine with the right diagonal. If win is not none, return win. And so now that we've checked every case, if there wasn't a win in any of these cases here, we can just say return none. Okay, so let's go up and just look at our list. We displayed the board, we ran the game, got the player movements, got the computer movements, and checked for a winner. Let's click check. But now we actually need to make sure that any of this works. So let us go to run and run. So please enter your movement. Let's go for the middle. Let's do 1, 1. Okay, computer placed an O in 2, 2. All right, let's try to win. Let's do 0, 1. So that'll be the top. Oh wow, did the computer just cut us off? Seriously? Okay, so let's actually cut off the computer before we lose. Now we gotta do 2, 0. Okay. And it might be, oh no, okay, yeah, we can still win going this way. So let's try out our diagonal by going to 0, 2. And we won, but nothing happened. And I think I know why. Because we actually never checked for a winner. So we'll say win equals self.check for winner. And what should we do? We need to check if we need to check what win is. So we'll say if win is not none, if win is equal to X, we'll print out a nice message for the player. Else if the win is equal to O, we'll just tell them you lost. And at this point, someone won, so we can finally get rid of this infinite while loop by breaking. It's hard to see here, but looking at the entire function, we have while the game's not over. While the game's not over, we get the player's movements, and then flip the turns. So I'll just say flip turns, and check for a winner. And then also display the grid. But we probably want to display the grid before we enter the winning message. So I'm just going to move that up there. And something that we also notice here is that we don't really need the game over we don't really need the game over uh, variable because we're right immediately someone wins, we exit out of the while loop. So we're not actually using self dot game over. So we'll just actually say while true, and we can go up and delete that game over and reformat. Let's go back down, and yeah, let's click run. So please enter your movement. Let's go for the middle, 1, 1. Let's go down here. That should be 1, 2. It'll let me click. Should be 1, 2. Oh, whoops. I thought I was an O for a second. Actually, can we even still win this? Oh, I'll try. Let me go here. Uh, so this will be 0, 1. And we'll try 2, 1 for the win. Ooh. And we did not win. So that seems to be an issue. So let's go up here. So it looked like a vertical one didn't work actually. So let's see how we can sort of debug to see why this is not working. Okay, so we're checking the verticals here. So I guess a faster way to check is let's turn off the computer's movements. So like only the player will move. Yeah, only the player will move. So let's just comment this out. Put a pass here, just so we can get some better debugging information. Okay. And let's look at checkline real quick. So when we do checkline, we're comparing a list to a predefined tuple. So remember that we're using self.playerWin and self.computerWin. So if we go back down to check for winner, let's actually open up the console and let's just make sure that actually works. Like, can we type in x equal to x true, or whoops, let's make it a tuple. Oh, false. Interesting. That's surprising. I was assuming that it would actually still be able to compare these element by element. I mean, because a tuple is immutable, and a list is still mutable, but we have a bunch of immutable objects within it. So that's actually something. This is kind of news to me. We'll probably have to change one of them. I think the easiest thing to do would probably just change player win to be a list and computer win to be a list as well, instead of casting each list we create to a tuple just for comparison. Uh, so let's try this again. I'm going to stop this and run it with just the player moves. So please enter your move. Let's just go down the first column. So we'll say 0, 0, 1, 0, 2, 0. You win. Nice. Process finished with exit code 0. So it found the winner and left the loop. Okay. So now let's put back in the computer movements. So I'm going to delete this pass and put back in the computer move. give it a reformat, then click run. Okay, so I kind of want to lose. So let's do 0, 0. Uh, then I'll go 1, 0. How do I make myself lose? Let's see. What's the worst thing I could do right now? What's the worst thing I could do? Probably, I think maybe going, let's see, if I went here, I cut off this. If I'd go here, I cut off 2. So I guess I should go to the place that cuts off the least amount of moves, which will probably be right here. So this will be 1, 2. All right, computer, you've got one job. Got one job. Hopefully it goes in a good spot. So I'm gonna go up here, and that should be 1, 1, or no, that should be 0, 1. Okay, yeah. So the computer finished it up with the diagonal. You lost. Okay, and so yeah, I know we tested a few of them. We just tested a single case of win and lose. Like, of course, if we're developing this for release, we'd probably want to do some like unit testing, test a bunch more cases, and probably clean up the code. But just wanted to show you how to get sort of a basic tic-tac-toe game functioning. And let me know if this tutorial was useful or if you want to see any more live coding in the future. But yeah, thank you.